Just a quick question. How many people here have know anything about Scalazzi? Just a quick show of hands. Okay. Since there's been it's kind of been a long night already, I was going to shorten my talk. I did this talk 2.5, 3 weeks ago in Boston. So if you, the parts that I'm not going to cover tonight, you could go there, and that's more comparing with Scalazzi and comparing Scalactic with Scalazzi. What I thought I'd do tonight, just off the cuff, I wrote on a little paper plate. Was just get a couple ideas across, and then we can talk about it. So how many people here are from East Bay, out of curiosity? Just, okay, more than half, that's good. I'm from the East Bay too. So anyway, what I would, I just wanted to get one idea across about how to deal with errors. Like if you write a method, and that method, something could go wrong, what do you do about it? System.exit. I'm not sure if that's technically a side effect, but anyway, that's one possibility. Another possibility is throw an exception. I mean, anybody, I just should have let you guess that one, but that's like the Java answer was to throw an exception, pretty much. So I have another answer called OR, which I'd like to kind of introduce and then compare that with exceptions and suggest how to figure out whether or not to throw an exception. That's what I thought I'd start with first. I thought that would be somewhat practical. So this thing called OR is in this library called Scalactic, which grew out of ScalaTest. Basically, there's been lots of user requests over the years. And one of them was for a way to accumulate errors, essentially. People wanted a way to find out all the assertion failures in a test. That was really the use case. That was the user request. So I had to figure out how to accumulate errors to solve that problem. And so what I came up with something called checkpoints, which is a imperative way of doing it, because ScalaTest throws, when an assertion fails, it throws an exception. And the reason it does that is to fail fast because of two reasons. One is a lot of times when something goes wrong up here in the test, if the test has got a bunch more things going on and more assertions down below, the ones after that usually don't actually matter to people, and they may even be nonsense errors at that point. In the old days, compilers, I remember that you'd like get an error at the top and then a bunch of errors that really don't matter. And nowadays they're better. They just like kind of give you the important errors. So that's what ScalaTest tries to do, is just get out quickly. Don't spend time executing the rest of the code, and don't waste your time with giving you a bunch of errors that don't matter to you, right? But I wanted to see, well, what would the functional way be of accumulating errors? And because in production code, the other thing that's happened over the years is when people ask for something in ScalaTest, they want something in their tests, they also wanted the same kind of thing to work in their production code. So that's where Scalactic came from. I didn't want people to put ScalaTest into their production code because it throws exceptions all the time. Usually when it's not happy, it complains by throwing an exception, and you really don't want to do that in your production code. So we carved out bits and pieces little by little and put them in this other library called Scalactic that's used by ScalaTest. That's its only Scala dependency. It's used by ScalaTest, but you can also use that piece in your production code. And so anyway, that's where OR came from, is sort of out of that process. And what it is it's a type that has two type parameters. The first type is the happy path. So if everything goes right, if a method returns an OR, it's going to return an int. I mean, basically, you might have a method that is, if things go well, it will return an int. If they don't go well, it will return the other one, right? So it's going to either return an int or an error message. So that's like, essentially, instead of throwing an exception, you put the error value in a return value. And then in Scala, you can actually write it this way. So any type in Scala that has two type parameters, you can use infix notation. Most people have, I mean, that's pretty rare that people write it that way, write types that way. Like you could do that with map. Yep, if you have a map from int to string, you could say int space map space string. That's a way to write it. So Scala allows you to do that with any type. And so I use that with OR just because when you have a method that returns it, so here's a parse name method. that takes a string and just checks if it's, after trimming, if it's empty, that's not a valid name. So that's either going to return a string, a valid string, a good one, or an error message, right? And then this other method down here is going to take a string and try to parse an int out of it. So it's going to return, this parse age method is going to return an int if everything goes well, or it'll return an error message. And that's like if something goes wrong. And the two things that could go wrong is one is when you call .toInt, that may blow up with a number format exception. And in that case, we return an error message, which is off the screen here, called input is not a valid integer. Otherwise, if it's negative, I decide that's not a valid age either. I give you a different error message which says that -3 is not a valid age. And so what this good and bad is that OR has two subtypes. I'm going to scroll to the top here. So there's two subtypes, good. Oh, now I need help holding my mic. Does anybody want to volunteer to hold my microphone? Alexi, all right, thank you. Just, it's directional, so I think you have to point it right at me. Or I'll point me at it. Okay, so. Okay, thank you. All right, so good and bad. So here's a very teeny tiny good. It would be better if it was big. And so it's just, there's one subtype of OR called good that takes one value of the first type, the good type. And there's another one called bad, which is also going to be teeny tiny here for a second. That, oops, that's OR. Where did bad go? I'll click on bad again and it'll go there. Okay, there's bad. So bad takes one of the bad types and extends OR, right? So it's either a good or a bad. So that's why when in this this method here, I return either good or bad. So let me see if I can find that again. Right here, let's use, make a little bit smaller. This parse age method, all right, I'll hang on for a second. This parse age method, if basically the age is greater than or equal to 0 and it's a valid int, then I return good age. Otherwise, I return bad some string because my bad type is error message. So that's basically how you can make a method return an error instead of throwing an exception with OR. Then if you have multiple methods that do that and you want to combine the outputs, then what you can do is use a for expression because an OR is monadic, so you can use it in for. It has a map and a flat map. And so I call parse name with some input string that's passed into parse person. And then I call parse age with some input age that's passed into parse person, right? And then I yield the person name comma age, and this is a case class that takes a string name and an int age. And if both the name and the age are good, then what you get out of that is a good person. So what parse person returns is a person or error message, right? So it'll be the good person or an error message, and what it's going to be is the first one that you hit. So it will short circuit in the monadic way. If the name is invalid, you'll get the error message about the name. Even if the int was invalid, it doesn't look at that. If the int's invalid but the name's okay, you'll hear an error message about the age being invalid. Otherwise, you get a good person. So what I think that actually what's going on is that way back when probably when Java was still called Oak, there was some discussion inside this very tiny group in Sun that created Oak about exceptions. And I think the idea of exceptions first came about because way back, even before that, I'm going to go way back to C days, the way you actually dealt with errors is by returning values, right? So you'd return, I know 0 meant okay, and I can't remember if we returned negative numbers or positive numbers for errors, but it was like 1 meant something, 2 meant something else, 3 meant something else. And the problem with that is people were, programmers were humans, and so they would just not check the result, the error, the return value to make sure, it say if this was a 1, then do this, if it was a 2, then do that. So what happened in C programs is that when an error did happen, it wasn't caught there. It was caught, it kind of percolated way downstream, and then later something blew up, and you couldn't figure out why, right? Because at the place where it happened, it wasn't checked, right? So that's what an exception was actually supposed to solve, because it fails fast. It does two things. One is it fails right away, blows up right there where the error first happens, which is better. And it also has this thing called a stack trace, so you can see how you got there. You have a little bit of information about how you got there. And then there's even sometimes a little message in the exception that says what went wrong. So that was all better than what had come before. And this fellow named, has anybody heard of Jim Waldo? He was at Sun way back when, and he had something to do with something called Genie. I don't know if you remember that. But he told the story that he was actually the guy who said, if we're going to say this is a type-safe language, we should be checking the types of these exceptions, because you got the same problem without checking them. You have the same problem of when someone throws an exception and it doesn't get handled, then you're not going to, basically the type checker is not going to say anything about that. So it's the same kind of problem of like unhandled exceptions. It's like unhandled return types in C, okay? So there was debate internally, and I don't think Gosling actually liked it. The story I heard is he did not like this checked exceptions idea. But when he was away for the weekend, somebody put it in. So it went in, and I think some people liked it, most people complained about it. And I found, my opinion was that it's the right idea, but the wrong technique. So what this does is it's like checked exceptions, except it's not an exception. It's back to the return type, like the old days of C, but it is actually something that's comfortable to manipulate and work with, because now you have functional things like these four expressions that are really like monadic transformations. So that's what's different. So it's like checked exceptions, except you're returning it. And I think it works much, much better because of the syntax for the functional transformations. That's my opinion. So the other thing that you can do with OR is accumulate. That's how actually I started out. So this doesn't accumulate errors. It just short circuits at the first one. You'll get the first error. And by the way, the other way this is different from exceptions is this error message here is a type alias for string, but it doesn't have to be a string. It could be any type. So there's a type called try in Scala, which is like this, except it's very much like this actually, except that the error type has to be a throwable. And I think that's an important type to have in Scala, because anything you do could blow up with an exception. So even if I have like something that returns a person or error message, the other thing that could happen because of a bug or I ran out of memory is this thing could blow up with an exception. So if I'm doing it async, like in a future or some other thread, I'm not there to actually catch an exception or see it even. So the only way to get it back to me is in something like this, but that it forces the error type to be a throwable. Yes, the guy in the yellow in the back.
Is the issue that your calling code has to then understand something might go wrong? I mean, the whole point of an unchecked exception is that you don't have to know that the called code might blow up, right? So like in Play, for example, you can make a global handler so that your controllers don't have to know that things might go wrong, but your global handler can catch them and then return a 4.0 whatever. So...
Yeah, I'm going to try to repeat the question.
How you're getting around the whole checked versus non-checked issue here, when you might just as well throw a runtime exception and let some other code that knows how to handle it, or not, or it just goes all the way back out the stack and then crashes. You
realize you just said "or" 4 times, which is good advertising. So. Yeah, I'm going to have to repeat your question, which I may not remember the whole thing. But basically what he's saying is, like, one of the ways you can handle a exception is letting it blow up all the way to the call stack to some global handler that does something common, like write into a log file, that's common. Or in the case of play, which you mentioned, it might return, well, you said 404, but it could return some error status or something. Yeah, 4 or something. Right, so I think, well, I haven't got yet to like what to use exceptions for, but that's, I mean, one of the things that exceptions do that this does not, which was actually one of the big pain points of checked exceptions, is it can go all the way back up the call stack. And so if you really want to not handle something in the 15 levels of method calls below that top level, it's really kind of convenient to be able to throw it all the way up, and these guys have clean interfaces. So it depends on the situation. So I'll come back to like when to throw exceptions, because there are times when you should, I think, in my opinion, and that's kind of one of the benefits. But the try thing, what I was just talking about, it is a different thread that when you go back to the top of it, it actually doesn't hit that global thing. So that's for like, you want to get it back across to your thread where maybe you want to throw it and then hit that global thing possibly. So that's what try, I think, achieves. So all these things are tools that fit different jobs, I think. So what try does is good for is a very specific thing of, I'm doing something async and I need to get the exception back to this thread, right? So try does that. And you need something like try that the error type is throwable. This one's more just general, where I want to return, I actually want to handle the error. It's not like something that I want to log or return some global thing, but I want the caller to actually handle it. That's what this is good for. And that's really what checked exceptions were supposed to be for, is that. So anyway, the other thing that I wanted to show you was in OR you can accumulate errors, which is sort of where I came from. What I did for that was made a bad type called every. Well, I'll show you. There's one called chain. So what a chain is a non-empty list, right? Essentially, a chain is like a list. It actually wraps a list, but it can never be empty. So that's called chain in Scalactic. And every is a non-empty vector. So what it is it's got two possible subtypes, one or many. So an every is, you can create an every like that with 1, 2, or 3 things. You can't make one that's empty. But if you create it with 1, then it's actually an instance of subclass 1. If you create it with more than 1, then it's an instance of subclass many. So that's what the two possibilities are. And what that allows you to do is make methods that return, if I can, Mike, what part of click aren't you getting? There we go. Good. Let's go back to or somewhere. There we go. Go back to one more. There we go. Let's scroll down to accumulating. So what you can say is I can change my parse name and my parse age methods to say they return one error message, which is an every. So I've now, it's actually a one or, this says in the type that it's only ever going to return 1. But if you have the bad type being an every in an OR, then it's accumulatable. So there's an API that will allow you to keep track of every error. Which might be useful, like if you're validating form input or something, you want to return all the different errors at once. So here I say this parse age now is going to return int or 1 error message. And then my parse person method, I'm going to have to move this over a little bit. Parse person is, I don't use a for expression because for expressions always short circuit. So there's this other API called with good. So one of the things I do is I actually invoke both parse name and parse age no matter what. They all both get invoked. And then you call with good with those two values. Those are both ORs. If they're both goods, you'll get back a good person using this function. It'll pass in the name, the good age, and you'll get back a good person. Otherwise, you get every error message. So you'll see, and that's actually now what the type says. The type says that parse person returns a person or every error message. So if only one of them is bad, you get back a 1. If both of them are bad, you'll get back a many that has 2 in it, right? So that's the API for accumulating errors. And so you can see down here, if I call this version of parse person with both of these are bad, you get back both of them, right? So again, this is, I think, an example of how the functional features of Scala make it comfortable and convenient and simple to deal with error returns. And it's like checked, not exceptions, but checked error values. So the good thing about checked error values is if somebody doesn't handle it, then it doesn't compile. So that was the goal of checked exceptions, and I think that's useful because this kind of error, I mean, the kind of errors that you would use this for is the kind of errors you would want people to handle. You would want to handle, and you want the compiler to remind you to do it, right? Then my next topic was just simply when to use exceptions, and my guideline for that was throw exceptions only at people, never at code. So like in Scala, in idiomatic Scala, the time when you want to throw an exception is when your program can't deal with it, except maybe that global way. So there's a bit of a gray area, but certainly if the program can recover and move on, or if this is like user input error and you're going to tell this information to the user, definitely you should use a functional return type like or option or try or any of these. Or Scalazzi has this disjunction type or validation type. There's all these different kinds of options you can use. But I think if your program can handle it, in other words, if there's code in your program that's going to handle this kind of error, put it in a functional error return. Otherwise, it's better to throw an exception because that's what they're for. Because they fail fast, you get a stack trace. It goes into either a log file or actually, when you return it to the user, you might also log it so that a developer can look at that stack trace and make some sense out of what went wrong, that sort of thing. So that was my half my talk. That was one concept. So before I move on to the second topic, do you want to, anybody have a comment about that? Criticism?
Well,
Yes.
How are you going to find the right person to send it to? I mean, a lot of times if your user is, the cashier with the long fingernails, you throw an exception to her, she's going to go out and smoke break. You don't have anything.
Oh, I should say, yeah. I should say throw exceptions only at developers, never at code or other non-developer humans, because, yeah, they won't know. But, yeah, what I meant by that was if your program is supposed to recover from an error, then in Scala you would not use an exception.
Well, that kind of goes back to the play thing, which, if you're an HTTP interface,
Yep.
you're throwing that 500 specifically to avoid doing that.
Yeah, so what I have found is that there was gray area. I mean, through exceptions only code, never people. If we're logging something, but then and we actually kill that, let's say, job that an app is doing, but the app continues, do you throw an exception or do you do a return? So sometimes it's like you could go either way. And so we've gone both ways before in the past. And what I found is I've actually wasted time because of not getting the type checking. So I would lean towards the functional error return usually. But what his point was, I think, was a good one, where if there's like 15 stack like method calls that really aren't going to handle that thing, then that sounds like a job for an exception. James, did you have?
Probably build a payload. If you had like 5 validation errors on one form,
Yep.
you could use this to build a payload that goes back with the 412 or 408 or whatever you want to do. And then the front end, like the Angular front end, can handle 412 in a generic way. And it says, oh, I know how to take these 5 failures and re-render the form with red things that say, hey, you've messed up on
Yep.
the seal or whatever.
Yeah, okay, what he said, just to repeat, he said basically you use something like a functional error handle, like something that accumulates errors to capture all of them. Maybe throw an exception up to the global handler, which sends something down to the client like a 412, some message that it knows how to pull out this information and put up on the form to help the user. So yeah. So anyway, I guess I kind of wanted to, I didn't want to give the impression that that exceptions are bad. They're just, they're a tool for a particular kind of job, which I think is different in Scala than it was in Java, just because Scala has these functional features. Okay, so that was that. Let me move on to the other one. So the only other thing I want to talk about was the role of tests versus types for quality. And I'm going to show one slide, which is that one. I was very proud of that slide. It's got circles and rectangles. So and it's got that word monad that everybody freaks out by. But what this is a picture of something that actually ended up in Scalactic because, again, it was a testing use case that I was trying to solve, which was laws testing. So one of the user requests that had happened repeatedly over the years was, how do I test that an object obeys the equality equals contract and hash code? It just seems like there should be an easy way to say this should pass the equal contract. And if you look at the equal contract, it's expressed in terms of mathematical laws of symmetry. I mean, you can write an equation. And the funny thing is, in the Java, in the Java Lang object Java doc, they don't actually write equations. They write them out in English, but they're actually mathematical. It's a mathematical contract. Symmetry and transitivity and reflexivity are the main three. There's one called non-nullity, which isn't very mathematical. It's not in the math, but and there's another one called consistency, which is because it's mutable, because objects can be mutable. But anyway, those are the five points of that contract. And what I wanted to draw here was that, to me, this is the idea of OO was always that there's this thing called an interface. That's what this rectangle is. And then back behind that is an implementation. And this is an instance. These are 3 instances, objects in memory. And so they have the interface, they have the implementation part. And the idea was that you abstract away detail with the interface. So there's a lot of detail in here about how this thing is working that we don't let through here. And then we connect the parts of our program by talking from interface to interface. I mean, basically we talk to interfaces, not implementations, and that allows us to make changes to the implementation without breaking the code that just relies on the interface, right? That's the idea. And the FP folks, they come from the perspective that from mathematics, I mean, like if you look at the Haskell way of doing things, they kind of are very guided by math, by algebra. And the way that can be brought to object-oriented programming is that this is just an object. A monad here is just an object. It's just an instance. It's got an implementation, and it's got a interface. But the interface, if you look at its contract, it's like the equals contract. It's just expressed in terms of mathematical laws. So I think that's actually useful because it's very clear what the abstraction is. If it passes that equation, then it's valid. I mean, in other words, your implementation is valid. And so it's a clear way to communicate the contract, which is, it doesn't have the ambiguities of just writing your contract in English. But it's also easy to test. You can use a property-based test, like with Scala check or quick check, to just write that equation in your test, and boom, it'll come up with a bunch of data to try to falsify it, right? So I think it has a lot of benefits. But it's essentially, there's 2 parts to this interface, no matter whether it's algebraic or human language, whether you describe the interface in terms of algebra, like equations, or human language. One part is just the signatures of the members, the fields and methods, and that is checked by the compiler, so that's type checking. The rest of it is called, I call it the contract, which is if you look at the Java doc or the Scala doc, you've got a human language description, or maybe occasionally it's equations. But that's the contract, and that has to be caught by tests. Right? So that's sort of the role of tests, is to test those contracts. And what I think FP has to offer OO is that basically what Scala is a object-oriented reform movement. That's where object-oriented programming originally was a lot about stateful or a mutable state. Objects had mutable state in them, and you encapsulate it, and you put the methods that work with that state in the object so that those are the only things that can access that state. What Scala says is that, now that we have modern garbage collectors, it's actually practical to make objects immutable, which is actually a very different idea. And that's what it does is it brings sort of all those benefits of FP that it's not an object-oriented stuff, but just functional programming. Object-oriented programs can actually enjoy those benefits. So anyway, that's what I wanted to say about that. And then the other thing, though, that I wanted to show you was that I think there's a limit of what you can do with types. So sure. Those are actually pointers or references. Let me. So this line here, you mean? Yeah. So this is essentially there's a monad, which is it's actually a type class. So I didn't show that it's square brackets type constructor. So there'd be a monad of list, or monad of option, or monad of or. All these things that are monads, you can make an instance of this for it, and then just use it in a method that just works with any kind of monad. So that's sort of the way you can abstract. And what I used it for was for testing. So the other kind of testing that I wanted to do myself was when I created this OR type, it's supposed to be a valid monad, and it's supposed to be a valid functor. And I wanted to say in ScalaTest, this should pass the monad laws somehow. And I couldn't. So that's what I've been working on for 6 months or something. And it requires that I actually create the same kind of type classes that you see in Scalazzi, which is monad and functor and applicative and that sort of thing, to do laws testing. And what this is an adapter class for an actual instance of the object that got a monad instance. So like OR is just an OR. So an OR is got an interface here, and it's got an implementation behind it, but it's valid if it implements what it says it does in its contract. So if you look at its Scala doc, it doesn't even talk about monads or anything, but it does happen to have a map and a flat map method that pass the monad laws. I mean, actually, I wanted it to do that, but I didn't have a good way to test it, right? So luckily, when I finally was able to test it, it did pass the laws already, because that's what it was supposed to do. So what you can do is if you create one of these guys, you can ask this to create an adapter that sort of, when you call map on this, it calls map on that. When you call flat map on this, it calls flat map on that. But you don't, if you are using this thing, you don't need to know which monad is behind it. You're just using that same interface. So these are this has a reference to the actual monad instance and a reference to the thing. It could be an OR, a list, an option, a future, a try, whatever. So that's what that is. And then the other thing I wanted to show you was just that I tried. Actually, let me kill some of these windows. This one, this one, this one, this one. Yeah, what I tried to do was actually get type safety on contains checks. I don't know if you guys are familiar, but actually Alexa, you want to hold my mic again, since you had so much fun last time? Thank you, I appreciate it. Just because I have to type and I don't have a lot of practice typing with one hand. What?
I followed the steps of Josh Sharef, who did this at the North.
Oh yeah, that's right. He was sitting right there, heckling. So, I need to make a different one because this one actually has. It's all right. This is good mood lighting. I'm going to make a different thing, and I'll say Scala. So if I say list 1, 2, 3, 1, 2, 30, that's fine. Dot contains, well, capital letters. Hello. What are you going to get? Yeah, I get false. So the fact is that this is a list event. List 1, 2, 30 is a list event. If I just say list 1, 2, 30 and get rid of this, you'll see it's a list event. That could not possibly contain a string in it, right? But so this is kind of a silly thing that passes the type checker. And so what I tried to do was find a way to get a type error for that. And I I did. I found a way to do it, but the trouble is that it actually relies on a implementation detail of type inference. So it's actually, if you type in any into this thing, it will compile. And so it's kind of a long story, but what Scalazzi did to deal with this is they actually make a different list. Basically, they don't like, the folks who've seen Haskell, once you've seen Haskell, you don't like that kind of type error. So they actually made their own list type called invariant list or iList that doesn't have that problem. And so one of the things that I have tried to do was figure out how to work with the standard library because it's the standard, essentially, and we all have to kind of use it. And so what I ended up doing is deciding it needs to be that you need to use static analysis to do it. So if I were doing a greenfield design? I mean, I would never spend my life this way. But if I were designing a programming language, and I'm going to spend 15 years doing that and building libraries, I would try to make this a type error. But there are trade-offs because there are actually benefits to making things covariant. And if you actually make that a type error, it makes it possible that someone could write an unsound contains method. So it's not necessarily an easy problem to solve unless you get rid of OO, right? So what I came up with was this compiler plugin called SuperSafe, which I wanted to demo. And it uses types, but not the type system. So you get a compiler error, but not a type error. So another example is if you look at regular Scala, because, well, not necessarily. It was a design decision of Martin Odersky, the people who designed Scala. But I think it actually makes sense. If you say 1 in a string equals the number 1, it just tells you false. And that's because the equals method in Java-lang object takes an object. So the double equals method in Scala.any takes an any, just to be compatible and simple. And it's really easy for everybody to understand. But then you get all these, I mean, what's really easy to do sometimes is say option of 1 equals 1. I mean, like comparing options with non-options just gives you false. And if you don't, so this kind of thing has to be caught in a test. And if you're writing tests, you'll usually catch it. But this is where I think you can use static analysis to find little problems like this. And there's a lot of things it can be used for.
Can you scroll up a little, Bill?
Sure.
Our glorious organizer is kind of in the way.
Oh, I gotcha. Yeah, so option 1 equals 1 compiles, right? And I've done this myself a lot of times in tests. That's where you do most equality comparisons, which is where this all came from originally. So in the if you use the plugin, the compiler plugin, and you say 1 equals 1, it doesn't compile, and it's you know, it has to look. If you make a set of list of 1, and that equals like say a set of vector of 1, you'll get a compiler error. It's not a type error actually. Wait a minute. I forgot one of my parentheses here. That was a syntax error. There you go. So that's the SuperSafe plugin that is giving you a compiler error by looking at the types, but it wouldn't be a type error. Because if you, it does things like if you say big int here, so now I've got a big int deep down on one side and an int on the other side, it actually compiles because that's true. So there's, oh, sorry. You know what I'll do is I'll move this. I can't see it either because there's this big microphone in front of me. So we all have obstacles. Let me move this up like this. Oh, Apple makes things so simple that I can't actually move my, let me do this, minus, 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 minus. Well, I'll do it this way. Essentially, if you have big int compared with an int deep down inside, that actually needs to compile because it can be true. Because big ints and ints cooperate. So there's all kinds of, like you notice it allows a list to be compared with a vector because those guys can be true also. So anyway, the point I wanted to make is I have come to the conclusion that there's really 3 prongs that you know if you can use types and it's practical use types, then that's the best way to do it. So like chain and every have in the type system that it's never empty. So that's an example of I can put something in the type, and then if my method takes that, then I don't have to compare, I don't have to say in my documentation, never pass in an empty list. You can't, because it wouldn't compile if you tried, right? That's the best thing. So try to get rid of requires and put it in the types. And then if you can't, then you're going to have to catch it in tests, right? So that's what, so Scalactic is really quality through types. ScalaTest is quality through tests. And then the other thing that I think is a useful tool is using a static analysis. And that's something I just released a couple weeks ago called SuperSafe, and it is a product. And I want to give away a free copy tonight for 1 year. And I had to kind of figure out how to do this. And so Alexei didn't have any like standard way to give away things. So I one time in the old days used to give design seminars with Bruce Eckel, and we want people to interact, and then some people never want to interact, right? They don't want to talk. And so I somehow learned from somebody that if you throw something in the audience and then the person who catches has to talk, then that's how you get everybody to talk, right? So I was back home in Indiana, and I told my stepmother, hey, I need something to throw into the class. And so we went down to the toy box in the basement, and she said, well, why don't you use this duck here? Because when you throw it at people, you can yell, duck! Which was pretty funny for my stepmother, considering. So what I'm going to do is I'm going to throw this out here, and then you have to throw it to you have to throw it two more times. So I don't want to like pick somebody. And the third person wins the raffle. All right, so this is actually a good thing. If you catch it the third time, you win. But you have to stay seated. You can't like stand up and fight each other, all right? So I'm going to throw it way to the back, and then that person throws, that's the second time. And the third time, that's the winner, okay? Agreed? All right. I'm going to hit the exit sign. Okay, I'm going to try to throw it over that. Let's see. Right here. Here we go. Yes. Oh, that's one. Nobody caught it. Yeah. Okay, throw it to somebody else. That's number 2. All right, third person. Whoever you throw it to, it wins. All right, there you go. Oh, I forgot to yell duck. Anyway, so that's all I had. I just didn't want to take too long since it was a long night already. But anybody have any questions or comments about any of these subjects? Yes?
I was wondering how you managed to achieve those funky return types with OR in the middle of them and your function declarations.
Yeah, that's actually a good question. You can do that with any type that has 2 type parameters, so I'm going to demo it with map. So I can say val mymap colon, I'm going to say string map int. I've never tried this before, so we'll see if I'm correct. I'll just say map of high to 1. Thank you. I was actually ho to 2. Let's see if that works. And then I'll move it up. Yep, that does work. So basically, map is a type that takes 2 type parameters. You can always stick in the middle. Don't do that. But I mean, if you think about it, function 1 takes 2 type parameters. Can you hold it for me? Because you're getting very good at that. Yeah. So if I say val fun colon function 1 int comma int, let's say, equals I colon int, I'll move this up to, again, rocket I plus 1. So this is an increment function. We don't usually write it that way. We have this intex. This is actually built into the Scala language. But we usually write it like this. So it's kind of like that, right? And so I think just every now and then there are types where it's nicer to do the infix thing. Yes, somebody else had a question somewhere. Yeah, James, one of the Jameses.
The loss testing, is that part of Select?
It's not yet. It's in master, so it'll probably be 2. Which one did we decide? 2.5. So we're going to have a bunch of, we actually had a bunch of things like the last year that nothing got finished, so we're starting to pump them out into little releases. But yeah, And it's not just, there's a monad type class there, but you'll be able to use any monad type class because there's one in Scalazzi. There's one in, there's some new ones coming out because Scalazzi had kind of a meltdown and some people offshoot. There were some offshoots. And so there's one called cats that's being worked on, another one called structures. So I will test it with all those to make sure you can use any one you want. Yeah. Anything else? Okay, well, thanks for coming. The guy that, yeah, come up. Oh, it's, aren't you from TypeSafe? Yeah. All right, perfect. Let's get this into TypeSafe.
One more time. I just spoke one more time with the person.
All right, sure. Okay, TypeSafe is gonna get. All right, here it comes. Look out! Oh, all right, thanks. Cool, thanks.